Good morning, students. Good morning, students. Welcome to the statistics class. Today, we will learn about features of normal distribution. Features, or we can also call them to be as properties of a normal curve. Properties of a normal curve. Normal distribution, you can say, or a normal curve, we can say. So, these are the properties you when you speak about them, so this is are the things that we can see for any type of a normal variable. Okay, so you understand this. uh, we will start discussing regarding these properties using one particular variable, uh, or example that is being mentioned to us is marks of the students. Okay, so marks of a students, when we consider that, and imagine you get a data of a student scoring from ranging from 0 to 100. Okay, say like this, I am just write it here like this as class intervals and the frequencies. So 0 to 10, the number of students. Okay, we can just get some data, right? 10 to 20, some data. 20 to 30, like this. If we go on having a data from till 90 to 100, and what are the values here? And this is what we call them to be as marks of a students in a particular class who has written the examination for 100 marks, and the ranging from 0 to 100. So the students are being grouped according to the marks that they have scored. Now, taking this data, and when we draw a frequency curve, we have studied the types of curves last year in PUC first year, or types of graphs in the last year. That is, one is histogram, one is a frequency polygon, another one is frequency curve, and last one is ogives. So when we represent this data, whatever data we have in hand, in the term of frequency curve, students, the curve will always have this kind of a shape, students. Okay, just understand. I am just doing it roughly to make you understand what would be the right the shape of the curve. Okay, so please bear with me because I am not using any tool to do that. So this is the shape of the curve, students. Always the shape will be like a bell. Okay. It is it is obvious for any of the variables, especially in a particular distribution, when we segregate them and when we group them and when we form a frequency distribution, this is the curve that we'll be getting. Now you may be understanding what this curve represents and what it is all about. Let me speak about this way. Okay, so understand, imagine here is the scale of the marks. This is whole of marks, students. This is whole of marks. Understand this? This is whole of marks. The scale is from 0 to 100. Okay, it is up to here 100. And now, if at all you take it as centimeters, 10 feet, 1 centimeter, 10, 20, 30, like this, 40, right? We have 50, then we have 60, then we have 70, then we have 80, then we have 90, like this. Just imagine, this is the scale that I have taken. Okay, these are the scores. And what this curve represents the number of students. Okay, the curve represents the number of students, like this data and this number of students. In the examination of 100 marks, and when it is conducted, and the scoring pattern of the students will form a bell-shaped curve. This is what I mean. The scoring pattern of the students will form a bell-shaped curve, students. Okay, what it is? If you speak and ask how many students have scored 0 marks, there will be few students who will be scoring 0 marks. There will be very few students who will be scoring 1 mark, 2 marks. And as the score starts to increase, the graph also starts to increase. You understand this? Okay, this is all number of students. So 20 marks, it starts to raise. 30 marks, again raised. 40 marks, it's raised. 50 marks, it's gone high. And at one particular point of time, right, it reaches the peak. And that particular point may be the middlemost value or the mode, whatever we consider. Again, after one particular point, like 53 or 54, according to this example, I'm just quoting, okay? It is not necessary that the value should be 50 or on 50, no, okay? I'm just taking some numerical value to make you understand. That's it. And when the mark is increased and asked how many students have scored 60, again the graph starts to decrease. 70, it starts to come down, right? 80 down, 90 down. And when we check it out and ask how many students have scored 100 out of 100, there'll be few students who scored 100 out of 100. So this is the same pattern, students, you understand, will be followed by every normal variable, whether it is income of persons, whether it is weights of students, whether it's heights of students, whether it's a rainfall, whether it is a temperature, whatever you can see, speak about, you always have this shape of the graph will take as bell shape, students. Okay, you understand this? So the first feature what we can speak and say is that the normal curve is a bell-shaped curve. A normal curve is a bell-shaped curve. This is going to happen for every normal variable. You understand this? I explained that to you. Okay, the next one is, they said is, if ever we consider this to be as, I'll take this as, I'll just erase these values so it should not confuse you. Okay, right. So this is, oh, so this is what we can call this to be as the mean, students. And the range of x stands from minus infinity to plus infinity. This you keep it in your mind. Okay, this is the middlemost value, and you understand this, the normal curve, okay. I'm going to give you all the easiest ones in the beginning so that it will be very easy for you to remember. If they ask, they'll ask for 5 marks. 5 simple points I'm going to explain to you in the beginning and later on some other points. The normal curve is symmetrical about the mean. Symmetrical about the mean, or in other words, from the central values. What does it mean here? 50% of the observations will be towards the negative side, that is towards minus infinity, and 50% of the observations will be towards the positive side, that of the infinity, towards the plus infinity. So in a normal distribution, if there are 100 observations, if ever I have to speak and explain to you, if there are 100 observations falling under this curve, 50 of the observations will be greater than mu, and 50 of the observations will be lesser than mu. This is what it means. Symmetrical means evenly balanced, and a symmetrical curve will always have this property. The property is that mean, median, and mode will be the same. Mean, median, mode will be the same. Okay, you understand this. Next feature that we come across is, the next feature that we come across is, they say that the normal distribution the normal distribution, okay, the normal distribution is unimodal distribution. Unimodal distribution. What do you mean by this unimodal? There is only one mode in the distribution. Understand? It's a unimodal. There will not be many values which will be repeated, or or we can say equal representation of the number of observations cannot happen. Right? If 20 and 30 we consider in a data, 20 also is repeated 13 times, 30 also is repeated 13 times. It can never happen. Any one particular value only will have more number of representations. That is the reason why normal distribution is considered as a unimodal distribution. There is only one mode in the distribution. Then the normal curve, okay, is a mesocurtic curve, students. Mesocurtic curve. This is all about the peakedness, students. This is all about peakedness that we have studied last year. Here, peakedness is measured or identified by beta 2, and the beta 2 value will be always 3. The normal curve is a mesocurtic. There are three types of kutosis. Kutosis, that is K-U-R, I can write it as K-U-R-T-O-S-I-S, kutosis. There are three types of kutosis or curves, we can say. Right? One is a normal curve. We call that to be as a mesocurtic curve. One which is above than the mesocurtic curve is called as leptocurtic curve. One is below the mesocurtic curve is called as a platycurtic. Mesocurtic is considered as a normal. We don't see any abnormality in the peakedness of the observations. Evenly balanced, right? We will not see the curve or the peakedness will be elongated, or we can't see it as flattened, but we can clearly say it's just a normal bulge. So the normal curve is a mesocurtic curve. Here the beta 2 is equal to 3. Then the fifth point I can tell you is that for a normal distribution, standard deviation is given as sigma, students. And if ever you have to find out quartile deviation QD, we can do it using this formula as 2 by 3 sigma approximately. Approximately, we can find out the quartile deviation using this formula as 2 by 3 sigma. And the next one that we can do is to find out the median, or so the mean deviation. Mean deviation can be found out approximately by 4 by 5 sigma. This also is approximation, students. Okay, approximately. I'll just make it as approximately. So these are the 5 points that you can remember. I feel you can remember very well easily, so that if they ask, mention 5 properties of a normal curve, these 5 properties you can write. There are many, students, right? I'll continue by writing this, students, okay? They say in a normal distribution, the upper and the lower quartiles, or you can say that Q1 and Q3, these are the lower and upper quartiles, are equidistant. You can say equidistant from median. If I have to speak about literally in this fashion, students, I'll just write this as a line. This is a scale. Okay, this is scale. If this is median, okay, evenly, this will be around 2 centimeters from median. This will be Q1. From here, from the median, 2 centimeters towards the right, this will be Q3. So they are equidistant from the median, students. Okay, so this is another important property The Q1 and Q3 are equidistant from the median in a normal distribution. So in that case, we also can find out the quartile, students. What is Q1? Q1, we have, using this formula we can find out, that is mu is equal, Q1 is equal to mu minus 0.6745 sigma, or the upper quartile we can find out as mu plus 0.6745 sigma. You have to remember these properties, you have to understand these properties, because all the 1 mark 2 mark questions that you come across in normal distributions will be based on the properties, students. Okay, so in a normal distribution, Q1 and Q3 are equidistant from the median. Okay, and Q1 can be found out by using this, and Q3 can be found out using this formula. Okay, right. The seventh one, students, the seventh point. What is the seventh point? The seventh point I can say is that, now getting back to this little mathematical terms or whatever it is, I'll speak in this way as the curve is asymptotic. These are mathematical terms. Asymptotic to x-axis, students. They are asymptotic to x-axis. What do you mean by this word asymptotic to x-axis? Okay, if I have to get back to the graph here, when we see this graph, students, right, you can see the graph, they say asymptotic means the graph touches the x-axis only at some infinity, minus infinity and plus infinity. It touches at minus infinity and plus infinity. This is what it means. But according to the mathematics, do we have any particular value for infinity? We don't have. So the graph just goes on nearer and nearer to x-axis, but it never touches the x-axis. This is what it means. The curve is asymptotic to x-axis. It means that the curve touches the x-axis at the infinity levels, but since we do not have any value for infinity, we can only say that the curve doesn't touch the x-axis, but it will be nearer and nearer to x-axis. This is what we mean regarding asymptotic to x-axis. Okay, this is what is the seventh point that you can remember. Okay, then we have something called eighth point. Right here we can say in this way: the curve has points of inflection, points of inflection. Right, these are some of the mathematical words, points of inflection. Okay, the curve has points of inflection at mu minus sigma and mu plus sigma, students. Okay, points of inflection. What does it mean, points of inflection? I'll just explain here a bit, right, and let you know about it. See, imagine if I start drawing a curve, like this. Suddenly, students, and when I start drawing the curve, change the direction of the curve. See here, I have changed the direction of the curve, and I'm going on like this. Suddenly, again, I bent, right? So these are the points which we call them where the curve is changing the direction. We call them as curvature points. What they're called as curvature points. So when we have such kind of things, those points are called as points of inflection. Now, where are these points in the normal curve? Let me get back to this uh, diagram. Okay, let me show it to you. Okay, certain points here, how you can draw these points and all. So it will be very easy for you, okay, to go through this diagram and understand all these concepts. Okay, so because whenever we are doing this, you need to be very clear with what is happening to us, right? Okay, fine. This is mu, students. Okay, this is mu. We have this as mu, and from the center, okay, you take one deviation, one value towards the negative side, one value towards the negative side. we call that to be as mu minus sigma. One value towards the positive side, we call this to be as mu plus sigma. One value towards another means 2 sigmas, we can say this as mu minus 2 sigma, and here also we can have it as mu plus 2 sigma. And again we can take one more value, we can call this to be as mu minus 3 sigma, 3 differences, and here also mu plus 3 sigma. This from here to here one sigma difference, again one more sigma difference, again one more sigma difference. Here also one sigma difference, another sigma difference, another sigma difference. So this is the first sigma limit. We call this whole part as the first sigma, this as the second sigma, and this as the third sigma, students. I hope you are understanding. Okay, so whenever we draw a curve, students, and the curve, when we start drawing it at one particular point time, from here the curve changes the direction, we can say this way. Again here it starts to change the direction. So here we have one point, here we have one point, and here we have another point. Okay, since you understand, since this is a symmetrical, here also is the same, here also it is the same, here also it is the same. Fine. So these are called as the points of inflection, students. Okay, these are the points of inflection. Now imagine, right, we can understand this. This is one particular, this is the one sigma limit, this is two sigma limits, and this is the three sigma limits. Okay, so this is one of the feature that we come across. Okay, curvature points. Right. Next one I can speak. Okay, is the most important one, the ninth one. Right, the total area under the curve, the total area under the curve, under the curve is unity, or in other words it is 1. Okay, what does it mean, students? What does that mean? Again we need to think about this diagram. What does it mean? That means that all the probabilities of all the variables of say for example the probability of a particular variable and probabilities of all the values of that variable are under this curve. Probabilities of the values of a particular variable are under this curve. The sum of all probabilities will always be equal to 1, right? That's why they said, we can say the area under this curve is unity. All the probabilities are under this, right? Now from mu towards positive side, from the mean, from this center point towards this infinity. Okay, what would be the area, what would be the probability of this? Will definitely be zero point 0.5, students. From probability, okay, the area of x greater than mu is what? It is always 0.5. And if at all we speak about this side, from this side to this side, from mu to towards minus infinity, all the values of x lesser than mu is also given as 0.5. You understand this? Okay, so this is very much important for us to understand, right? And another one thing is the sigma limits here, they say is that what is the probability that a value will lie here. Okay, that I will just release, I will speak about this area property in the next class, students. I think this will be too much, so okay, I'll do about the area property in the next class.